This is Long-Term Actuarial Models, Chapter 3, Lecture 1, and this lecture deals with life tables. The first question I'd like to look at is sort of as simple as it can be. It's to use the select life table at the right to find the probability that a life currently age 75 who's just been selected will survive to age 85. Okay, so in other words, we're trying to find 10p75, but to indicate that this life was selected at 75, some underwriting was done, checking their health. I'm going to put brackets around it. And 10p75, or the probability of surviving from age 75 to age 85, is L85 over L75, but again, I need to put brackets around it to indicate that this is a select life. And I can calculate that as L85, we can see is 10,542. And then if I look at lives selected at age 75, I'm looking at the age on the left, and I can think of the lives as moving right and then down. I need to divide that by 15,930. And when I do that division, I get 0.66177. And that's the complete answer to that question. Slightly more complicated, I want us to compare some results we get for select lives and non-select lives. So first, I'm going to calculate the probability that someone 77-year-olds today that hasn't been selected survives the next 7 years and then dies in the ensuing 2. So that's 72Q77. So in order for that to happen, the person has to survive 7 years. So I need to take 7P77. And I need to multiply that by the probability that a person 84 years old dies in the ensuing 2 years. Okay. And no selection of any kind is taken place. Now we know how to do 7p77 already. We know that that's L84 over L77. Okay, and 2q84 is just 1 minus the probability of surviving those 2 years. So that's 1 minus L86 over L84. And if I put all those numbers in, everything's non-select, so I'm reading ages off the right-hand side of the table. L84 is 11,250. Divided by L77, 15,286. Okay, times 1 minus L86, that's looking like 9812. Divided by, what's left there? L84, that's this guy. So 11,250. Okay, and if you crunch those numbers, it turns out I got that that's 0.094073. And we'll need this number in a minute because we're going to compare it to what happens if 77 was a select life. Before we do that, I just want to mention, you may have noticed up here that I could multiply through there, and this quantity we're looking for is L84 minus L86, all divided by L77. So I want to point out that this probability of living 7 years and dying in the ensuing 2 for a 77-year-old is just equal to the number of people that die between ages 84 and 86. We can think of that as 2D84, the number who decrement during that time, divided by L77. That'll give you the same quantity, and it can sometimes be an easier way to do the calculation. The next question, for question 3, we're going to do exactly the same question, except now we have a select life, a life that's been selected at age 77. So as you might imagine, the work's very similar. We want 7p77, but now it's a select life, and we want that times, it's only a 2-year select period we can see here. So once we get up to age 84, doesn't matter, it's going to be the exact same quantity as before. So 2q84. The work is very similar. I'll go ahead and write it out for completeness. It's, let's see if I can write it out for completeness. It's L84 divided by L77 in brackets this time. It's a pretty poor L up there. Okay, times 1 minus just what we had before, 1 minus L86 over L84. Okay, and if you put in those two numbers and work it out, I have it written down here, you get, let's see, 0.095548. And that's greater than the number we got before, which was 0.094073. So it's kind of surprising that someone selected at age 77 here has a higher probability of dying between ages 84 and 86 than someone who wasn't selected at age 77. I would say it's slightly counterintuitive. But if you think about it, it makes sense. Everyone dies. If you're less likely to die during the select period, you must be more likely to die after the select period. So that's the way I think of that. Okay, slightly more complicated example to finish off. Use the select table at right to find the probability that a life currently age 76 who was selected 1 year ago. So they were selected at age 75. They're currently 76. So I'm interested in that guy. So just for the record, L sub 75 plus 1 is equal to 15,668. So we might need that in a minute. And I want the probability that they will die between ages 85 and 87. Okay, so that's, let's see. So I'm interested in 9, 2, Q sub 75 plus 1. Okay, and that equals 9p 75 plus 1. First they have to survive 9 years, and then they have to die in the ensuing 2. We're way outside the select period by then, so that's just 2q85. And if I put those numbers together, that's the probability of surviving the first 9 years. It's just L85 divided by L, I have to write this carefully, 75 plus 1, where the 75 is in brackets, times 1 minus, we've done this a few times now, L87 over L85. And fill in those numbers, and you get 0.09433. Excellent. Okay, this has been Lecture 1 from Long-Term Actuarial Models, Chapter 3. There'll be another lecture on assumptions for fractional year assumptions for the year of death, UDD and CFM in the next lecture.